In this video I shall present the solutions for the second part of test 12. Exercise 1. Draw on the exam paper a trunk of square regular pyramid ABCD A', B', C', D'. First we draw a parallelogram which represents the base of the regular square pyramid from which the trunk comes. Then we draw the diagonals of the parallelogram, and from the center of the parallelogram, which is given by the intersection of the diagonals, we draw the height of the pyramid. Then we connect the tip of the pyramid, which coincides with the tip of the height of the pyramid, with points A, B, C, and D respectively, and thus we have drawn the pyramid from which the trunk comes from. Then we section the pyramid with the plane parallel to the base ABCD and remove the small pyramid by rubbing it out with an eraser, and thus we have drawn the trunk. Exercise number 2. If x belongs to the set of real numbers different from 0 so that x plus 1 over x equals 4, determine the value of the sum x squared plus 1 over x squared. We write x plus 1 over x equals 4 and raise both members to the power of 2. This gives x squared plus 2 times x times 1 over x plus 1 over x squared equals 16. Which is equivalent to x squared plus 2 plus 1 over x squared equals 16. So x squared plus 1 over x squared is equal to 16 minus 2, which is equal to 14. Exercise number 3. Determine the lowest natural number which, divided by 15, 30, and 45, gives each time a quotient different from 0 and a remainder of 13. First, we write the theorem of division with remainder, where the dividend is equal to the divisor times quotient plus remainder. Then we substitute in the theorem of division with remainder the values known for the divisor and the remainder, and obtain three equations where d is equal to 15q plus 13, d is equal to 30q plus 13, and d is equal to 45q plus 13. For d is equal to 103, all these three conditions are satisfied simultaneously, so the number we are looking for is 103. Exercise number 4. Consider the function f defined on the set of real numbers with values in the set of real numbers. F of x is equal to x minus 6. Point A. Graphically represent the function f in a coordinate system x, y. Point B. Calculate the product f of 0 times f of 1 times f of 2 times dots times f of 99 times f of 100. In point A, in order to draw the graph of the function f, we first calculate the intersection point with the OX and OY axes respectively. Here I have used the shorthand method for determining the intersection points compared to one of my previous videos in which I have calculate the intersection points by doing f of x equals 0 for the intersection point with the OX axis, and f of 0 for the intersection point with the OY axis. Here the intersection point with the OX axis is point A of coordinates minus b over a and 0. Notice that the function f can also be written in the form ax plus b. Here a is equal to 1 and b is equal to minus 6. So a has the coordinates minus 6 over 1 and 0. So a has the coordinates 6 and 0. The intersection point with the OY axis is point B of coordinates 0 and b, so it is point B of coordinates 0 and minus 6. We draw the system of coordinates and choose an unit of distance. Then we mark the points according to the coordinates found, and then we draw a line which connects points A and B, and this represents the graph of the function f. Note that because function f is a first degree function, its graph will be a straight line. Point B. The product f of 0 times f of 1 times f of 2 times dots times f of 99 times f of 100 is equal to minus 6 times minus 5 times minus 4 times dots times 93 times 94. However, f of 6 is equal to 6 minus 6, which is equal to 0. So we have one factor of 0 in this product, so the whole product will be equal to 0. Exercise number 5. Consider the expression e of x is equal to x squared plus 4x plus 3 times x squared plus 3x plus 2, everything over x squared plus 5x plus 6, where x is a real number, x is different from minus 3 and minus 2. Prove that the expression is greater or equal than 0 for any real number x different from minus 3 and minus 2. We notice that each factor both in the numerator and the denominator are second degree equations. So we can decompose each of these second degree equations into a product of factors. First we take x squared plus 4x plus 3. We notice that delta is equal to 4, so x1 and x2 will be equal to minus 3 and minus 1 respectively. So x squared plus 4x plus 3 can be written as x plus 1 times x plus 3. According to the formula, x minus x1 times x minus x2. The same method applies for x squared plus 3x plus 2, where delta is equal to 1. So x1 will be minus 2 and x2 will be minus 1. So x squared plus 3x plus 2 is equal to x plus 1 times x plus 2. The same rule applies for x squared plus 5x plus 6, which can be written as x plus 3 times x plus 2. We substitute the products we found into the expression, and obtain that E of x is equal to x plus 1 times x plus 3 times x plus 1 times x plus 2, everything over x plus 2 times x plus 3. We simplify x plus 2 with x plus 2 and x plus 3 from the denominator with x plus 3 from the numerator. And the expression is equal to x plus 1 everything squared, which is always greater than or equal to 0 for any x belonging to the set of real numbers without minus 3 and minus 2. This was the second part of test 12. Thank you for your attention.